In this capsule, we will focus on electronegativity. I have written this here, periodic table, periodicity. We know the periodic table from the previous classes. Um, so one of the more important aspects of the periodicity is electronegativity for organic compounds. So here I have copied from one of the textbooks that I have, I think Francis Carey. So the data, this is the groups 1A, 2A, 3A, 4A, those are the groups, and here you have the rows, that's the periods. So first row has hydrogen, and then you have the noble gas helium there, and second row lithium ending with neon, and then you have the noble gases there, krypton, xenon, and as the shells increase, you have more second row, third row, fourth row, fifth row, and all that. But in this one, we'll just look at the electronegativity. So I have given these numbers, though in red, I have the atoms and electronegativity numbers in red. Some of the more important ones for organic chemistry. Okay. So what is electronegativity? Electronegativity can be defined as the tendency of an atom to pull electrons towards itself, when it forms a bond with something else. So for example, let's say take carbon oxygen bond. Let's say there's a carbon oxygen bond in a molecule. It's it has all other things, but we're just focusing on carbon oxygen, so we omitted everything else. So carbon oxygen. If you look at these numbers here, carbon electronegativity is 2.5, oxygen is 3.5, meaning oxygen is more electronegative than carbon. Okay, so oxygen has a greater tendency to pull the electrons. Of course, they're sharing one electron. Oxygen brought one electron, carbon brought one electron. They shared, they formed a bond. But once the bond forms, oxygen is like, hey, I want more share of that. I have better electronegativity, larger electronegativity than carbon. So the bonded electrons, the two electrons, are pulled towards oxygen. That's electronegativity. So if you have a bond between carbon and carbon, see, those two atoms, carbon and carbon, have the same electronegativity. So the electrons between the two carbons are equally shared. But take any other element, carbon and any other element, there is a disparity in the electronegativity. So the electrons in the bond between carbon and some other atom, say hydrogen or oxygen or chlorine, they are not shared equally. There is some pull, tug. One of the elements will be more electronegative, so electrons tend to move towards that element in the bond. So in this bond, carbon-oxygen, electrons tend to move towards oxygen. Oxygen has more electrons from that bond. So oxygen, we say, has a partial negative charge. That is the important thing here. On that, the entire organic chemistry reactions depend. Which one has the partial negative charge, which atom has a partial positive charge. So now as you see, we'll come to that again in a minute. As you see from the periodic table, you notice something, right? The electronegativity increases this way. Electronegativity increases as you move from left to right, and electronegativity is decreasing as you go from top to bottom. Okay? So keep this in mind. This is a good thing to remember. I mean, you do not need to remember the actual numbers, That's no one recommends that. But what you need to remember is the trends. Remember the trend. Trend is your friend. Remember the trends. Trend is your friend in organic. Of course, there will be exceptions. Trend is your friend. I think I borrowed that from the stock market, but doesn't matter. It's true. So, electronegativity increases from left to right and decreases from top to bottom. So you see hydrogen, row 1, electronegativity is 2.1, and it's decreasing. Lithium is 1.0, sodium is 0.9, fluorine is 4, chlorine is 3, bromine is 2.8, iodine is 2.5. So see the trend as you go down the periodic table, it decreases. So now I need to erase this to talk about related materials. So let's draw different bonds with carbon and see how the electrons will be in that bond. We can start with carbon, nitrogen, carbon, oxygen, carbon, fluorine. Okay, some carbon, carbon as a reference. Carbon, carbon, both of them have the same electronegativity, so the bonds are equal. The two electrons, these two electrons, that's a bond, so two electrons are equally shared. So neither atom is getting more electrons. Let's move to carbon, nitrogen. Carbon, nitrogen, carbon, from the table, I think it's 2.5, nitrogen electronegativity is 3, so nitrogen is 3, maybe I'm off a bit, 2.5 and electronegativity of nitrogen is 3. So nitrogen is more electronegative, so these two electrons are not equally shared between carbon and nitrogen. Nitrogen will get a bit more electrons. So then we say that nitrogen will have a delta negative and carbon will have a delta positive, which we write them as partial positive charge on the partial positive charge on the carbon, and it's denoted by delta plus, and nitrogen will have a partial negative charge denoted by delta minus. Okay, and many times I tend to abbreviate partial positive as like that, plus sign, plus and V, positive and negative like that, just shorthand. But carbon will have a partial positive charge, nitrogen will have a partial negative charge. Now, if we move to oxygen, carbon, oxygen, oxygen electronegativity is 3.5, this is 2.5, so again oxygen will have a delta minus, carbon will have delta plus. Moving to carbon, fluorine, fluorine is the highest, is the element with the highest electronegativity, so that will have. Now, so in all this bonds, it's not fully fleshed out, we just focused on carbon, nitrogen, carbon, oxygen, carbon, fluorine. So we're not showing any other carbons, any other hydrogens, we're just focused on that bond. So we're not showing anything else. But you see, in these three cases, carbon has a partial positive charge, another element, nitrogen, oxygen, fluorine, have a partial negative charge. Now, okay, extending this further, if you have a carbon, hydrogen, carbon, lithium, lithium is a metal. Sodium, the first group, second group elements, those are metals, lithium, sodium, potassium, and magnesium, beryllium, magnesium, calcium, all those things are metals. So, and metals are not as electronegative as any other elements. So, if you recall, if you can rewind and watch the video, rewind and look at the numbers I have for the metals. Carbon is 2.5 and lithium is 1. The electronegativity of carbon is 2.5 and the electronegativity of lithium is 1. So what do you think will be the charges now? Suddenly, carbon has a delta negative charge and metal will have, the electrons are not equally shared. Carbon is now getting the electrons. So this is what enables the synthetic chemists to do all sorts of reactions, manipulate this type of subtle differences in the elements to come up with, different compounds useful in, any fields. There's no field without organic chemistry, right? So this is one of the foundational concepts. So anytime you see a carbon connected to any other element, more often than not, there is a partial positive charge or partial negative charge on the carbon. So now that leads to another discussion about the types of bonds, which I'm sure you are well aware from the previous courses, but we'll add something more to what we already know. So you're very well aware of, bonds like that, hydrogen, compounds like that. So you have 2 oxygen atoms, 2 hydrogen atoms, 2 nitrogen atoms. These are all purely covalent bonds. The electrons are equally shared between the 2 atoms. But when you come to compounds like this, it's not so, right? So then you see there's a partial positive and a partial negative. So these bonds are not purely covalent. So we came up with, the chemists came up with a new terminology which explains more correctly the type of bond. It's a polar covalent bond. It's not pure covalent, it's polar covalent. It's not ionic either. Ionic bonds that you see, like compounds like sodium chloride and Na+Cl-. But these compounds, in these bonds, carbon, nitrogen, carbon, oxygen, anything, carbon, bromine, carbon, chlorine, these compounds, they're polar covalent, polar. They're somewhat more polar. And now, again, trend. Okay, which one, if I put a question like this on the exam, you have these 3 bonds, carbon, nitrogen, carbon, oxygen, carbon, fluorine. Arrange them in the order of most polar bond to least polar bond. How will you do that? You look at this, you do not need to remember the numbers, exact numbers, but you remember the trend, right? Trend goes that way. Across the periodic table, electronegativity increases. So carbon-fluorine bond, you see, here I have the numbers. So the difference between carbon and fluorine, electronegativity-wise, is quite high. It's about 1.5. So the bond, carbon-fluorine bond, is polarized more towards the fluorine. And it is most seen here. As you come this way, coming to the left, here it's only 1 and here it's only 0.5, the difference. So the most polar covalent bond will be the carbon-fluorine one, followed by the carbon-oxygen one, and then followed by the carbon-nitrogen one. So we have introduced a new thing called polar covalent bond. And because of this became possible because of the electronegativity differences. And this foundational concept, polar covalent bond and electronegativity, okay, they play a crucial role in organic and the physical properties and chemical properties of compounds. For example, let's look at not an organic compound, but let's take a look at water, H2O, which you are familiar with again. So let's look at oxygen electronegativity is 3.5, hydrogen is 2.1. So you can see which one is this a purely covalent bond? No, because of the different atoms. There's oxygen-hydrogen bond, oxygen-hydrogen bond. So since oxygen is more electronegative, oxygen will have a delta negative charge. It will have slightly more electron density, although it's bringing in electrons to share with the hydrogen. Once that is done, the electrons are tilted or moved towards the oxygen more, and as a result, each hydrogen atom will have a delta positive charge. Hydrogen atom. So again, polar covalent bond, and this phenomenon is of this water molecule is what gives rise to hydrogen bonding, and which I'm sure you know from previous classes. And because of the extent of hydrogen bonding, the boiling point of water is quite high, as we know it. So all the phenomenon that we see, the underlying, the fundamental reasons are here. The electronegativity differences, the polar covalent bonds. And this is one of the things we need to understand, master. Anytime you see bond carbon, bromine, you should be immediately able to say carbon will have a delta plus, bromine will have delta minus. Okay. So once we master that, we can move on to another concept. Okay. So good. So we'll stop here and continue in another video.